So anyway, we're continuing with room 3 here. We're going to have Ashish will be talking to us about mitigating open source software supply chain attacks. Ashish, the floor is yours again. Thank you.
Thank you. Yeah. So let me turn your attention to software supply chain attacks, particularly on the foundation of our digital infrastructure, which is open source software. So in the last 10 years, we have literally gone from software eating the world to open source software eating the world. It is the standard way of developing digital products and services. According to a Synopsys report, it makes 70% of our software. Modern software, open source software, is distributed as packages and published on package managers. There are millions of packages available on npm, pypy, and other package managers. And the code is actually sourced by installing packages. So for Python, you would say pip install package name. So anybody can publish package on these package managers, individual developers, groups, and companies. That means software that we run on our servers, laptops, phones, coffee machines, you name it. It's actually written by unknown volunteers, which we blindly trust. So there are bad actors that capitalize on our trust. They exploit weaknesses in the code that we source and also the way we source it. So let's talk about the first part, which is weaknesses in the code, also known as vulnerabilities, right? So these are programming bugs. They are introduced accidentally, for example, buffer overflow. And they pose indirect threats in the sense they need an exploit to trigger the buggy code, and they may not always have a high impact, and can typically be fixed by upgrading to the latest version release. So what are some of the weaknesses in the distribution process, the way we source open source software packages? Well, for first, anybody can publish their packages using their credentials. There are very few or no checks or code vetting. Packages are searched and installed using names. Source code is not shown. So bad actors actually exploit new attack vectors to propagate malware. In the last couple of years, we have seen a lot of malware detected in npm, Python, pypy, and Ruby gems. So what are some of these malware? So let's look at some case studies. So this is MITM Proxy 2 package. It uses a typo-squatting attack. It impersonates a popular package with similar name, MITM Proxy. And notice how it has the same project description and other attributes. So this technique exploits the typo during installation, and a developer may have a typo, or it capitalizes on developers' inexperience when remembering name or not knowing the name. So this package, while it has the same metadata, same creates a facade, the code actually is different from the original package. It has removed all the safeguards. So anybody on the same network can execute a code on your machine with a single HTTP request. Let's look at another example. This is REST client package from Ruby gems. It has over 100 million downloads. So this has this piece of malware in this, which downloads a payload from Pastebin and executes it. And notice how it only does it for on production environment. And it installs a remote code execution backdoor on web servers. So hopefully I've convinced you that unlike vulnerabilities, malware is intentionally harmful code, not accidental programming bug. For example, it could be a backdoor. And it poses very direct and dangerous threats. It itself is an exploit. It doesn't need any other exploit. It's obfuscated to avoid detection. And it's typically hidden in popular packages for wider reach. It's also evasive. As you saw, it only triggers under narrow conditions. And it can only be fixed by yanking malicious dependency versions. So what can you do? How can you improve the sourcing process? So today, when we source a package, we look at number of GitHub stars, open issues, number of downloads, documentation, perhaps test cases. However, these are attacker controlled. For example, stars for download, there could be a download bot that can create fake number of downloads for a package. Project description, website, documentation are impersonated, so they look the same. Now the question is, should we look at package code and hundreds of dependencies? It's not feasible, right? So that's the focus of our work. We focus on detecting malware in open source software. I'm Ashish. I'm a research scientist at OSSIBOT. I recently graduated with a PhD from Georgia Tech. I'm a creator of EXDifuse file system, which uses eBPF for better performance. In the past, I created a 32-bit operating system that boots from a floppy disk. For those who don't know what floppy disks look like, I have an image of floppy disk here. So the work that we do started as a research project at Georgia Tech. We downloaded and analyzed over 1.3 million npm PyPy Ruby packages, and we were able to detect 339 previously unknown malware. 82% of those were confirmed. Many of them were year old, and you can find details in this academic paper. Now we are funded by NSF to continue our development and find more malicious packages, help developers. And we have built a technology for continuous scanning of packages. We currently support PyPy. So this is what it looks like. We download millions of packages that are published. We look at the source code. We also download metadata, and we also look at the project development activity. And we have developed a deep analysis learning engine. So we start from static analysis, we look at abstract syntax tree, we look at APIs being called, we do dynamic analysis, we look at if a package on installation is trying to steal your SSH keys or communicates with the blacklisted server. And we also do metadata analysis. So these are some of our recent findings. We found a bunch of malware. For example, this IDO Dino it's been around for some time. It was released in 2018, still valid on PyPy. So let's look at some of these. For example, this particular malware, Christian. So this, as you can see from the code, this has code for it detects that the platform is Windows and Linux. And it downloads a script it downloads the script from the internet, and then it executes the script with hidden output. And this is another piece of malware that we detected. It does something similar. It downloads a payload from the internet, and then it spawns a subprocess, and it executes the subprocess. So we are announcing 3 free tools for developers today in beta that can help developers when sourcing software packages. Basically, they're supposed to be smart assistants. So the first one is Package Explorer. It's a web app on our website. You can search for packages and see if there are issues with them. The other one is a command line tool, which is a simple PyPy package that contacts our server and alerts you if there are any known problems or problems that we have found. Finally, we are also shipping a GitHub Action plugin that will help developers with reviewing a pull request. If there are issues that we have detected, we'll alert developers. And we can find malicious packages. We can also flag suspicious or potentially malicious packages so that you can review. We also look at CVEs and can flag vulnerable packages containing known CVEs. And then you can customize for undesirable properties. For example, if you don't want to source a non-reputable package, then we'll alert you. So let me show you quickly the functionality. All right. Can you see the screen? So this is our website, oscillate.com. So you can sign up for free and go and look at the details here, the type of attacks we detect. And so if you go and search here, you'll be able to search for packages. For example, this is the package that you can search for, and you can see it's undesirable here. So if you go and click on this, you'll be presented with a page like this. You can look at when it was released, if it has a home page or not, similar packages, and then if there is a project description, and it says right here it's undesirable, right? And it talks about this latest version. So you can log into customize the type of alerts that you want to receive. So once you log in, you can go to the settings page, and you'll be able to configure what type of alerts you want to receive. For example, if you want to be alerted of any malicious packages we found, and if there are any undesirable properties that that you want to be alerted about. For example, if there's no public source repo, there's no test suite, there's no inactive community, if the package is suspicious, if it's overriding system binaries, or if it's vulnerable. And finally, we are also shipping a command line tool. It will work in this way. So you'll be able to, when you're installing a package, it will check against our database, and it will alert you of any problems that we found. For example, in this case, easy install is a Python package that downloads a malware and adds to the file system, and you'll be able to review the full report. All right. So that's it. Thank you so much for attending the talk. You can visit us at oscillate.com or write to us at hello@oscillate.com. And finally, we have a Slack community that you can join and help us detect open source software malware. Thank you so much. And I'd be happy to take any questions. You're not audible. I think your microphone is muted. Yes.
So out of curiosity, how often do you see typo-squatting attacks involving like Unicode characters?
Unicode characters. I don't think we have the data handy, but typo-squatting is one of the most common attacking techniques. You can find the details in the paper. We've found about, I think, over 200 typo-squatting packages out of 339. So a lot of packages were typo-squatted.
Okay. I'm waiting for, I think somebody is asking a question in Element. We'll get it in here real quick. Yeah. That's a good question. Which Python static analysis tool is Oscillate using?
So we built our own static analysis tool. We basically build a abstract syntax tree, and we look at the APIs that are being used. For example, if file system APIs are being used, or network APIs are being used, or sub-process APIs, for example, also eval API is being used. And then we try to do taint analysis. It's not complete, but we try to detect if they are trying to download something and then feed it to eval and then basically run that. So we detect cases like that.
I don't see any other questions. So thank you very much, Ashish.
Thank you.